All right, so 7.5 is going to be over 2 new focus graphs, and I say new, they're not new. We have learned them before, okay? First one's quadratics, and second one's polynomials. So we're going to start with quadratics. What does a quadratic function look like on a graph? Yes, a U shape. Out of every single graph that we have done this year, these should be the ones that come the most natural to you. Okay, we have spent the most time on quadratics. We have really hammered these, okay? So there's no reason why we should be missing quadratic questions or we shouldn't know how to graph a quadratic. Okay, this should be very straightforward. If we have a quadratic, the domain is always, always, always going to be negative infinity, positive infinity, okay? The range is going to change, right, depending on if this thing is a right side up U or an upside down U, okay? If it's upside down, the range is going to go from negative infinity to the y value of your vertex, which is the k, we called it. Or if the u is right side up or positive, it's going to go from k to positive infinity. Are we good on that? Okay. Again, that should be really straightforward. Those should be really easy for us by now. Those don't have asymptotes, right? They don't have holes. Okay, so don't let that confuse you. Then we have what we call polynomial functions. We just briefly talked about this in our warm-up. What is a polynomial function, or what do they look like? It's a polynomial. What unit was that? We did what kind of problems? Factoring, right? So these kind of look like factoring problems. Look like a factoring problem. It's going to have x to a power, right? So like some examples of this might be like y equals x to the third plus 2, or y equals x squared minus 4. Y equals x squared minus 4 is also a quadratic, right? So am I saying here that a quadratic is a polynomial? Yep, it is. Okay, but polynomials, just like a square is a rectangle, right? Okay, other things are rectangles as well, right? Not just squares. So quadratics are polynomials, but there are other polynomials besides quadratics, and that's what we're going to deal with today. We've seen them a little bit this year, but not a whole lot, okay? The domain on a quadratic is going to be what? Negative infinity, positive infinity. Okay, what about the range on a polynomial? What do we say? This one actually is going to depend on what it is. So depend on the highest power. This is going to depend on the highest power involved. Okay, domain is always going to be negative infinity, positive infinity, but the range is going to depend on what the highest power is. Okay, because we're going to be looking at quadratics, we're going to be looking at cubics, we're going to be looking at quartics, which is power of what? 4. So powers of 2, 3, and 4. Okay. That's probably as high as we're going to go today, or it is as high as we're going to go today, but you could go up to powers of 5, 6, and beyond, okay? But the range is going to depend on what that power is. And so we'll take a look at some different examples. We're going to start with number 1, okay? Again, we have seen this before. We would call this standard or vertex form. Standard or vertex form. Vertex. This is vertex form. If it was standard form, it would be written as like y equals negative x squared minus whatever plus whatever, okay? But this is definitely vertex form because we've got that negative h and we've got k, okay? When we were graphing this by hand, we would pull out that vertex, we'd write it down, we'd make a table, and we'd graph this, okay? But we have Desmos as our best friend this unit, so that's what we're using today. So you need to go and you need to plug this guy in to Desmos, graph it, and then tell me all those blanks. So I'm going to give you like 3-4 minutes to do this. We'll go over it and we'll move on. Okay, the limits both go down to negative infinity. Max was 3, 2, right? Why is it a max and not a min? Highest point, top of a hill, right? Okay, intervals. This is where a lot of us mess up, so make sure that we are really paying attention to this. No matter what, our intervals should add up to our domain, okay, no matter what type of function this is. So whenever you are doing intervals, you should never be writing the range numbers, okay? This 2 it's not important, okay? So make sure whenever you have your increasing, decreasing interval, yes, we're increasing all the way up to this vertex point. We all agree that, right? We can see that we're increasing to that point. But what I want you to write is negative infinity to the 3, okay? Because that's the domain of it. And then you're decreasing from 3 to positive infinity. Because again, it's domain when you're writing those intervals. So don't get that confused with the range numbers. And then the intercept should have been pretty straightforward. I think I rounded those x-intercepts to get 4.4 and 1.6. And then the y-intercept was 0, -7. One thing, too, that I've got to be really, really straightforward on, okay? Moving forward this unit on the quizzes and the tests, I will not accept x and y intercepts that are written in the wrong order, okay? I usually took off like half a point if you put for the y-intercept -7, 0 instead of 0, -7. I won't do that anymore, okay? There's no reason you should be getting those wrong because it's given to you. You literally just have to click on it. Okay? Cool. All right, example 2. Go ahead and do this one as well. Type it in just like that. Give me the graph and give me all the answers. So check your answer with this work, okay? Another, what do we call this? What would we classify this as?
Quadratic.
It is a quadratic. Is it also a polynomial?
Yeah.
Yes, good. Negative infinity, positive infinity for domain. The range, bottom to top. So we're starting at -7 on that y-axis and we're going to infinity. No asymptotes, no holes. Limits both go to positive infinity because they're both going up. We have a minimum, right? Increasing from 3 to infinity. Decreasing from negative infinity to 3. Again, those domains, those intervals should add up to your domain. So from left to right, what is happening, okay? We also know that it's going through our line of symmetry, so that's the number we should be including in there, okay? So that should be 3. X-intercepts, y-intercepts, I rounded them for the x, but again, you should have those same things because Desmos gives you that. Okay, questions on that? One thing, too, to be clear on, x-intercepts are also called zeros, right? So if you see that on the EOC, don't freak out, okay? We know what that means. It's the same thing as an x-intercept. Cool. Okay, we're going to skip number 3 for right now because I like example 5 better for cubics. So we're going to go to example 5. We're going to do example 5, and then we're going to do example 4, and then we're working on our homework for the rest of today. So I want you to type this into Desmos and at least put the graph on here to the best of your ability, okay? You may want to label some of the points too. So put the graph on here and then try your best to answer as many of these as you can, okay? We'll go over them shortly. Number 5. We're going to do 5 first and then we'll go to 4. Okay, so do we all agree that the high point here, I have it labeled, the low point here, I have that labeled? Do we all agree that the domain and the range are both negative infinity, positive infinity? We all understand why that is. Left forever, right forever, down forever, up forever. Okay? So, we should all have that at least. Do we have any asymptotes or holes yet? Or no? No, we don't. We hadn't learned that yet when we learned how to graph cubics. Okay, so we do not have that. The limits, so again, copy down the domain for x approaching negative infinity, positive infinity. As x goes left, y is also going to negative infinity. As x goes right, y is also going to positive infinity, okay? So if you got those, great. If you didn't, it won't be on the EOC, so you're okay. Max and min, what do we think? Do we have a max and min? This is relative, though. So relatively speaking, if we look at that, do we see a hill and a valley? Yeah, we do. So relatively speaking, there is a hill and there is a valley here, okay? We talked about last class. Negative infinity, positive infinity are never going to be relative extrema, okay? It's got to be an actual point. It's got to be a point where we change direction. Are we all clear on that? So would you agree that right here, we are changing direction? And that would be the top or the bottom of a hill? That'd be a max, right? So that's just going to be the point. Negative 2.7, comma 10.4. What about min? Yep, we got a bottom too. Okay? And again, if this line like continued and it didn't do what it does up here, okay, if it just continued down, that would not be a minimum, okay? It's only a minimum because we changed direction. Okay. Increasing and decreasing intervals. These get a little tricky with these, okay? And if you remember, this was probably the hardest interval we ever had to do in this class, okay? So from left to right, okay, we know that domain goes to negative infinity and to positive infinity. So starting from the left, from negative infinity to what? What are we doing first? We're increasing first, yep, and we're going to negative 2.7 because again, it's the x value. So from negative infinity to negative 2.7, we are increasing. So we close it off, okay? Negative infinity to negative 2.7, we increased. Now we pick right back up where we left off at negative 2.7, but we are now decreasing to where? 0.7, good. And we pick right back up where we left off, which is 0.7. We are now increasing to, infinity. We don't have another change of direction. So we are going to union that with 0.7 to infinity. And we're done. That's it. And if we want to go back and we want to double check, if this was a roller coaster, starting from left to right, I increase once, I decrease once, I increase once, right? Don't draw that. That was really ugly, okay? But that told me 2 increases, 1 decrease, and that's what I have. Okay? X and Y intercept, these should be easy. What are they? Perfect. And Y intercept? 0, negative what? Negative 8? Cool. Anything else? Nope, we're good. Questions on that? Okay, number 4 and we're done. Number 4 and we're done. So try that one out. Okay, so check your answers with this. What did this one look like? An upside down U, we call those? Quadratics? Is it a quadratic though? No, it's not. It is a what? Quartic, right? A power of 4 is a quartic. So here's the thing. Sometimes these are going to look like quadratics. Other times they're not, okay? And you're going to notice on your homework, I can't remember what number it is. I think it might be like number 9. It's a quartic, and it doesn't look like a quadratic, okay? So don't freak out if that happens, because it doesn't always work like this, okay? But this one did work like a quadratic, so all of the answers were the same as what a quadratic would be. Negative infinity, positive infinity, negative infinity to 0 for the range. Limits both went to negative infinity. The max was 0, 0. So were the x and y intercepts. We increased from negative infinity to 0, and we decreased from 0 to infinity. Questions on that? Okay, so the ones on your homework, it's lots of practice. They're not all going to be identical to what we did up here. They're going to look a little different, okay? But if you have a question, I'm going to be coming around. Ask me, okay? I would love to help you. No reason why we should have a bunch of homework tonight. You should be done or almost done by the time you walk out the door today.